Okay, so next here we're going to have a look at 19.4. So from a bucket of spring water containing dissolved calcium chloride and calcium hydrogen carbonate, 500 centimeters cubed of the water were accurately measured into a beaker and then boiled for about 30 minutes. When cool, the water from the beaker was filtered into a 500 centimeters cube volumetric flask. Deionized water was then poured through the filter paper into the flask, and finally the flask was made up to the mark, again using deionized water. Okay, the water from the volumetric flask was then titrated in 100 centimeters volumes using 0.01 molar solution of EDTA. The mean titration was 6.0, and then when the measurement was repeated using 100 centimeters cubed of the unboiled water from the bucket, the mean titration was 19.0. So first what we're going to look at is this part here. Okay, so this is when the water has been boiled. So I'm just going to put in here a little thing here of boiled. Okay. And I'm just going to look at the information that I'm given. I'm told 100 centimeters cubed of my hard water required 0.01 molar of my EDTA. And I'm told that in my boiled water, I had 6.0 centimeters cubed of this used. Okay, so again, I start off here, 0.01 molarity means moles in 1,000 centimeters cubed. In this question, I haven't used 1,000 centimeters cubed. I've only used 6 centimeters cubed. So 0.01 multiplied by 6 divided by 1,000. And that gives me 6 by 10 to the minus 5 moles. That's my number of moles of EDTA. So next then I'm going to set that up as a ratio with my calcium ions, 1:1. So if I have 6 by 10 to the minus 5 moles of EDTA, I'm also going to have 6 by 10 to the minus 5 moles of calcium carbonate. So that's 6 by 10 to the minus 5 moles, and that's in 100 centimeters cubed. I want to find out how much is in moles per litre, which is in 1,000 centimeters cubed. So multiply 6 by 10 to the minus 5 by 1,000 divided by 100, and that gives me 6 by 10 to the minus 4 moles. Okay, next then what I'm going to do is I am going to work that out in grams per litre. So number of moles equals my mass in grams divided by my relative molecular mass of CaCO3. That's 40 plus 12 plus 16 by 3, which gives me an answer of 100. So 6 by 10 to the minus 4 multiplied by 100. And that gives me an answer of 0.06 grams per litre. Finally, I need to convert that into milligrams per litre or ppm. So I multiply that by 1,000 and it gives me 60 ppm. So that is the answer there to the one that's been boiled. Now, what I'm going to do is I'm actually going to repeat this then for the one that was unboiled. So again, I have H2X2 minus plus Ca2 plus goes to CaX2 minus plus 2H plus. And just here, I'm going to put in unboiled. Okay, so this was when or before it was boiled. So again, I've used 0.01 molar here. Again, I repeated it using 100 centimeters cubed. So my 100 centimeters cubed is going here. But from the unboiled water, my mean titration here was 19.0 centimeters cubed. So I'm just going to do the exact same here. 0.01 moles is in 1,000 centimeters cubed, but when it was unboiled, it took 19 centimeters cubed of EDTA. So 0.01 by 19 divided by 1,000 gives an answer of 1.9 by 10 to the minus 4 moles. My ratio of EDTA is to Ca2 plus is 1:1. So that's 1.9 by 10 to the minus 4. Gives me 1.9 by 10 to the minus 4 moles. That 1.9 by 10 to the minus 4 moles is what's in 100 centimeters cubed. So I need to find out my moles in 1,000 centimeters cubed. So multiply 1.9 by 10 to the minus 4 divided by 100. You get 1.9 by 10 to the minus 3 moles. Next then again, I need to work out my grams per litre. So number of moles equals mass in grams divided by my relative molecular mass of CaCO3. 40 plus 12 plus 16 by 3 gives me 100. Okay, so 1.9 by 10 to the minus 3 multiplied by 100 is going to give me 0.19 grams per litre. Okay. Next then, we're going to work out my ppm. So multiply by 1,000 and that gives me 190 ppm. Okay, right. So if we look there then, we're asked calculate the total hardness of the bucket expressed as parts per million of calcium carbonate. So the total hardness of the bucket is going to be the amount of hardness that was there before boiling. So the total hardness is 190 ppm. Okay. The next thing then that we're asked is the hardness that is caused due to calcium hydrogen carbonate. And the important thing to link here is that this is temporary hardness, and temporary hardness is hardness that can be removed by boiling. So in order to work out how much of my temporary hardness, it's going to be the difference of the total hardness and the hardness that was left. So my total hardness was 190. I boiled it and I was still left with 60. So 130 ppm there is what is down to my calcium hydrogen carbonate.